Okay, we have returned an integral from the MIT integration bee 2019, number 19. We've got the integral of 2x cubed minus 1 over x times x cubed plus 1 dx. Okay, to get started with it, there's a few different ways you could go. You could go to partial fractions, you could go to algebra. I think what I'm going to do instead is u substitution. I want to clean up this x cubed and try to simplify it that way. So I'm going to do u equal to x cubed. That means x is going to be just u to the 1/3. Take a derivative, so then dx is going to be 1/3 u minus 2/3 du. So then we'll go ahead and substitute and see what happens. So the numerator becomes x cubed is u, so this is just going to become 2u minus 1. In the denominator, this here is u 1/3. That looks messy. Here, this is just going to become u plus 1, and our dx value, the 1/3 I'll bring up front as a constant. U minus 2/3, let's bring that into the denominator as u 2/3 du. But here we've got the same base, so let's just multiply those together. U 1/3 times u 2/3, that's just going to be u to the 1. And now at this point we could do partial fractions, and I think it'd be easier than what we had here, but I'm going to kind of do it on the fly because really what we're trying to do is I want to create cancellation. So what I'm going to want is something with a u in it, something with a u plus 1 in it, in order that we can split this up into 2. And so it's a matter of kind of seeing what works. If we subtract these two, then you'll notice distributing in the minus sign, we get our minus 1. But then here we're going to have u minus u, that's just going to be a 0. We want to get back to 2u. The way we can force this is if I make this a 3u. 3u minus u gives me the 2u minus 1. So now we'll go ahead and we'll break this up into two different integrals. The first one is going to be this 3u, so we'll have 1/3 3u over u plus 1. Distribute the 1/3 into the minus sign, we have minus 1/3, sorry, there's a du right there. And then this is going to become just u plus 1 over u times u plus 1 du. But then I can cancel u's right here. I can cancel 3's over here. I can cancel u plus 1 over here. And now what we're left with, two easy integrals. Go ahead and integrate. The first one's going to be just natural log absolute value u plus 1 minus 1/3. And here we get natural log absolute value of u. Let's go ahead and back substitute with our u value here. So what's going to happen, this becomes, let me write it down here. So this is going to become ln absolute value x cubed plus 1. And then over here, minus 1/3 natural log x cubed. But then here with the exponent properties, you can distribute the 1/3 in, or you can take the 3 out. Either way, those are going to cancel, and we can just get rid of that on the exponent and the coefficient. But then with log properties, we can put these two together, divide the x into this, and for my final solution to this, we get natural log absolute value x into x cubed is x squared plus 1 over x, add a plus c, and that's it. Okay, so there you go. Interesting problem today from MIT 2019. Thanks everyone for watching. Have a good day.